In this topic, we'll finish discussing Assemblies V1, introducing one more new Java collection interface, set. And we'll look at some practical issues related to implementations of set and map. Now that we understand getCatalog, let's look at how the returned map is used in main. Main prints every component by name, followed by its weight. But to do this, it must know the value of every key in the map. Question 1, by the way, can we just iterate through a map like catalog here, as we would a list, for instance? Can we just change this to for string comp name on catalog, and then do something with each key in the catalog in turn? Answer that based on the requirements for a for each loop, which we have discussed before, and on the map Java docs. And then getting an answer here, looking at the map interface. The short answer is no, we can't. Catalog, the map, would need an iterator method that returns an iterator in order to use a for each loop on it. And map has no such method. Extra credit, by the way, if you also said that map would need to implement the iterable interface. We'll talk more about that interface when we get to Assemblies v3, as a matter of fact. So, instead, the main loop calls keySet on catalog, and this returns a collection keys of just the keys in catalog, which collection does provide an iterator and therefore can be used in a for each loop. And using keys, the loop retrieves each component in the catalog and then reports its weight. But as the declaration of keys indicates, the result of keySet is not a list, it's a set, which is yet another new collection class interface. So let's look set up in the Java docs and see what it does. And of course, I'll ask you a few questions here. How do I add something to a set? And how does this differ from, say, adding an element to a list? There's an important behavior difference. And based on that, why is it more reasonable for keySet to return a set than a list? Well, you just call add is the answer, and down here, and pretty much as you would for a list. But if the object being added is already in the set, then the add will fail. A set, as its name implies, allows only one copy of any object. And since each key in a map must be unique, there are no duplicate keys, then it makes sense for the keys to be returned as a set, not a list. So, question 3 here. Okay, so is a set just a list that's particular about duplicates? Does it behave in all other respects just like a list? Could we perhaps subclass set from list, adding just the requirement that add not allow duplicates? So presuming you went and checked the interfaces and compared them a bit, then the answer here is no, there is another important thing that list does that set does not. List maintains objects as an indexed order, or in an indexed order, like an array. One may add an object to a list at a particular index, and you can retrieve an object from the list, again, at a particular index. Set can't do that. Indeed, set has no get method at all. The only way to get its content is via an iterator. So set couldn't be derived from list. A subclass must do everything its superclass does, plus perhaps a few more methods. Now, here we get to a very important concept regarding the collection classes. When you use collections of objects, such as strings or components, it's important to understand that they are collections of references. When you add an object to such a collection, you add a reference, not a duplicate object. So, for instance, as the diagram here shows, if we have code like this, where we create a list of strings and then a couple of string objects, and then we add them to the list, it does not create more than 2 string objects. There's not an S1 string in the caller and then another S1 in the list, a copy of that object in the list. Instead, the list shares the same data. And as a dramatic example, we could even add a couple more lines of code here to the end of our sample. And this adds a second reference to S1 and a null value to boot, with the result as shown here in the diagram. Now list contains 4 references, 2 of them to the same string object, and 1 of them null. And note, by the way, that many collection classes can contain nulls, although it's not usually useful to add them. So this brings us to question 4. With this in mind, let's return to the set interface. Say I have a set collection. Could I add 2 different string objects to it if they have the same content? They'd be different references, right? At the diagram to see what I mean. Could I create a set, stir set, and a couple of string objects, each containing hello, and then add them both to the set? Would the second add fail or succeed? Again, one argument might be that it would succeed because they are different references after all, and therefore there would be different references in the set. Another argument would say no, that it'll fail because they have identical content. Justify your answer based on the Java docs, and review the concept of shallow versus deep equality from an earlier topic, if needed. So, looking at that answer then, the Java docs for set method add state that no 2 objects in the set may match according to the equals method. So deep equality is the rule. You certainly can't add the same reference to a set twice, but you also can't add 2 different references if their targets have equal content, according to the equals method. So in our case here, obviously this second add will fail. Now set, like map and list, is an interface. And as with those 2 other interfaces, the Java collection classes provide several implementations. HashSet, for instance, implements a set using a hash map, a hash table, I should say. And TreeSet implements it using a binary search tree, again technically a red-black tree. You can think of these implementations as keys-only versions of hash map and tree map. Question 5. Which kind of set would you guess is returned by our key set call in process orders? And by the way, how might that explain the somewhat random order of the component names in the output? I'll rerun that here. This random order here. Turning from a pause there. Well, given that the catalog itself was originally a hash map, it makes sense to guess that keyset would return a hash set. And this is correct to a first approximation. We'll look more closely at this in the next segment. And since the order in which keys are put into a hash table is dependent on their hash codes, it's not surprising that an iterator that is marching through the hash table might encounter keys in an apparently random order like this. And then question 6, if keys were a hash tree instead, then we might expect correctly that its iterator would return values in sorted order, since the binary tree keeps its data in sorted order. So what small change to get catalog, and I do want it to be in get catalog, not main, what small change to get catalog would make keys a hash tree and would print these components in name order? And the answer is probably pretty obvious, and that's that we would need to allocate a tree map instead of a hash map. And then we'd expect the result of a key set to be in sorted order, and the output likewise to be in sorted order, as you can see when we run the code just now with that change. Now in a later segment we'll look more closely at the practical issues surrounding hash versus tree implementations, but for now remember that the tree implementation keeps values in sorted order, and that can be an advantage. So this wraps up our discussion of assemblies v1. And in the next segment, we'll look at a design pattern illustrated by key set, and then move on to assemblies v2.